In this video, I'll show you how to solve the ALEKS problem called counting valence electrons in an atomic ion. This problem is going to give us the symbol of an ion. It could be either positively charged like mine is or negatively charged. I will talk about how to solve the problem if you have a negatively charged ion. And it wants you to determine how many valence electrons are in that ion. The valence electrons are the number of electrons on the outermost surface of an atom or an ion, and they are indicated on the periodic table by the numbering system that uses letters A or B. So I'm circling the relevant numbering system right now. And so the way that you would read this is all of the elements in this particular column, group 1A, they all have one valence electron. And in the next column over, all of these elements have two valence electrons, and we typically don't talk about valence electrons with these guys in general chemistry. So scooting all the way over to the other side of the periodic table, all of the elements in this column have 3 valence electrons, and these elements have 4 valence electrons, and you get the idea. So your first job is to find your element based on its symbol. Mine is Ra. There it is on the periodic table. Your second job is to see what column that element is in. This guy normally, as an atom, has 2 valence electrons. Actually going to write it up a little higher. So this one normally has 2 valence electrons. Now that is not the answer to this question. This, as an atom, this guy has 2 valence electrons, but we are not looking at an atom. We are looking at an ion. This is a cation, and that means that it has lost electrons. Specifically, it has lost 2 electrons. I know that because it has that 2+ charge. So and the electrons that it loses are coming out of the what we call the valence shell or the valence area. So if this thing started with 2 valence electrons and then it lost 2 of them based on its charge, it now has a total of 0 valence electrons. That's not very exciting. Let's pretend like this was, just to make it a little bit more exciting, let's pretend like it was, we will do B+. Let's say that was our atom, and we wanted to know how many valence electrons there were. We would need to find boron. It's right here. We would look to see what group it's in. It's in group 3. That means as an atom, it normally has 3 valence electrons. The plus sign means that it has lost 1, and so it would have, now it would have 2. So 3 because it is in group 3A. We're subtracting 1 because it has a charge of +1. And that +1 charge means that it's lost an electron, and this is now the number of valence electrons that it has. Now, if we have an anion, the difference here with an anion is that it has gained electrons. So an anion has gained electrons, and the number of electrons gained is going to be indicated by the charge. So let's use boron again. Let's say that we had boron and it was a -2 ion, and it was asking us how many valence electrons are there. Well, because of boron's location on the periodic table, we know that the boron atom starts with 3 valence electrons. The charge means that it has gained electrons. Anions have gained electrons. The 2 tells us how many electrons it has gained, and now that would mean that it has 5 valence electrons. Again, that 3 is because it is in group 3A, starting with 3 valence electrons. 2 because it has a charge of -2, indicating that it has gained 2 electrons.